All right, so let's check out this guy right here. What we're going to be doing is that we're going to be adding and subtracting, and then I have down here multiplying, dividing now functions themselves. So instead of evaluating like we did in example 1, we're now actually going to add the functions and actually just do the 4 operations. So f plus g of x is the same as f of x plus g of x. Okay, we know that. Now, we can replace f of x with what's given to us. Well, f of x is 3x plus 4. Okay, so I just replaced f of x with 3x plus 4. And now I can replace g of x with x squared minus 3. I'm sorry, minus 3. And now all we do is we just combine like terms. So there's only one x squared term. So I'm going to leave that right there. There's only one x term. So that's my 3x. But then we can combine the 4 minus 3, which is positive 1. Okay. Coming over here now. Again, f minus g of x means f of x minus g of x. So what we want to do is we want to just substitute and simplify. Again, f of x is 3x plus 4. Minus is very important here. Put minus g of x. So that means I'm going to put g of x in parentheses because it's more than one term. It's x squared minus 3, which is important because now we have to distribute this minus sign. Okay, so that's what I'm going to do right here. So I'm just going to first do this, and I'm going to distribute negative times a positive is a negative x squared, and then a positive 3 because negative times a negative is positive. Okay, now we combine terms. We bring down the negative x squared term, bring down the 3x, but then we can combine 4 plus 3 is 7. All right, so now let's do the same for multiplying and dividing these guys. So this means f of x times g of x. And so f of x is 3x plus 4. G of x is x squared minus 3. All right, so we'll have to expand this now. So we'll do FOIL, right? You know, the first inner, outer, last. So 3x times x squared is a 3x cubed. 3x times negative 3 is a minus 9x. 4 times a positive x squared is a positive 4x squared. And 4 times negative 3 is negative 12. And combining like terms, there are actually none of the terms we can combine together because this has the power of 3, power of 1, power of 2, and this doesn't have a power. So we probably just want to put in descending order, starting with the highest exponent going to the lowest. So 3x cubed plus 4x squared minus 9x minus 12. So notice this has a power of 3, power of 2, power of 1. And if you want to think about this, this actually has the power of 0 because x to the power of 0, this is just 1 times negative 12, which is just negative 12. So this is called descending order here. All right, let's finish this guy off. So this means f of x all over g of x. Okay, our f of x, again, is 3x plus 4. Our g of x is x squared minus 3. All right, and now we don't want to just quite leave it like this because basically we're saying that this is true for every x. Like if I plug in 1 for x, if I plug in 2, it's always true. Well, is there a value that you can't plug into this, meaning that it's going to give you a non-real answer? Like it'll be imaginary. And basically we don't want the denominator ever to be 0, right? So the answer is actually this, where x is not equal to some value. Well, if I take the denominator and I set it equal to 0 and I solve for x, so I add 3 to both sides, and then I take the square root, so I get x equals plus or minus radical 3. What does this mean? It means if I were to plug in square root of 3 or negative square root of 3, we would get 0 in the denominator. And if you ever get 0 in the denominator, that means that it's not possible. I mean, it's not even an imaginary number. It's not even possible. So really the answer should be this, where x is not equal to plus or minus square root of 3. That's the real answer. And so just keep that in mind. Anytime that you have a rational expression, if you have some kind of variables in the denominator, you need to indicate what values can x, or the variable, what values can they not be. In order to figure that out, you set the denominator equal to 0. You solve for your variable, and now those are the value or values that do not work for this rational expression.